Hello friends, today we are going to study ERTMS bar ETCS STM level, which stands for Specific Transmission Module Level. As we know, the European Rail Traffic Management System was developed in Europe to create a common and interoperable railway signaling system. One of the major challenges in European railways was that each country had its own national train protection system. The STM level was introduced to solve this problem and allow trains equipped with ETCS to operate even on lines that use different national protection systems. Let us first understand what STM means. STM stands for Specific Transmission Module. It is a special module that allows the ETCS onboard system to communicate with the existing national train protection systems. The main objective is to ensure interoperability. Interoperability means that trains should be able to move freely across different countries without changing locomotives or installing multiple signaling systems. With STM, a train equipped with the ETCS can safely operate even on tracks that are not equipped with the European system. Need for STM. Now let us understand why STM is required. Before the introduction of ERTMS, every European country had its own signaling and train protection system. For example, Germany, France, Italy and Spain all had different systems. If a train wanted to run across borders, it had to carry multiple onboard signal reception devices corresponding to each national system. This made locomotives very complicated, expensive and difficult to maintain. STM solves this problem by acting as an interface between ETCS onboard equipment and the national ATP system. Concept of STM. Now let us see the basic concept of STM. STM receives the signal coming from the national train protection system installed on the track. These signals are then converted through a standard interface and transmitted to the onboard ETCS computer known as EuroCab. The EuroCab processes this information and displays it to the driver through the driver-machine interface. So the information flow is national signaling system, STM module, EuroCab and driver display. In this way, the ETCS equipped train can understand the national signaling information. STM architecture. Let us briefly look at the system architecture. The system consists of the following main components. First, the national train protection system, which provides signaling information. Second, the STM module, which acts as the translator between the national system and the ETCS onboard equipment. Third, the EuroCab onboard computer, which processes the information. Finally, the driver-machine interface, where the driver receives the instruction. This architecture ensures smooth communication between different signaling technologies. Operation of STM level. Now we will see how the STM system operates. When a train is running in an area where only the national protection system is installed, the STM module becomes active. It interprets the signals from the national system and provides the required train protection function. From the driver's point of view, the operation continues normally, and the train remains protected according to the national system rules. Thus, STM ensures operational continuity even when ETCS infrastructure is not present. switching between systems. An important feature of STM operation is automatic switching between systems. This switching occurs when the train detects a Euroballast installed on the track. Euroballasts are electronic beacons placed between the rails. They transmit information to the train when it passes over them. When the train enters the ETCS equipped section, the Euroballast signals the onboard system to switch from STM mode to ETCS mode. Similarly, when the train leaves the ETCS territory and enters a national signaling zone, the system automatically switches back to ATM system. This transition happens automatically without requiring driver intervention. Role of optical signals. Next, let us discuss the role of trackside optical signals. Depending on the national signaling system, side optical signals may still be required. In some national systems, drivers rely on traditional signals placed beside the track. However, in other systems where cab signaling is fully available, these external signals may not be necessary. Therefore, whether trackside signals are required or not depends on the technology and functionality of the national protection system. Level of supervision. Another important point to remember is the level of supervision provided by STM. The STM system can only provide the same level of supervision as the national system. It cannot improve or exceed the safety capability of the underlying system. For example, if the national system provides basic speed supervision, STM will provide the same level of protection but not more. Therefore, the safety level during STM operation is equivalent to the national train protection system. Train detection. Now let us discuss train detection. In STM operation, the ETCS system itself does not perform train location or train integrity detection. These functions are handled by external systems belonging to the national signaling infrastructure. Usually, train detection is performed by track circuits or axle counters installed along the track. These systems detect the presence of trains and ensure safe train separation. Thus, train detection remains the responsibility of the trackside national signaling system. Advantages of STM. STM provides several important advantages. First, it allows cross-border operation of trains without installing multiple signaling systems. Second, it reduces the complexity and cost of locomotives. Third, it ensures smooth transition from existing national systems to the ETCS standard. Fourth, it supports gradual modernization of a railway signaling infrastructure. Because of these benefits, STM plays an important role during the transition phase towards full ETCS implementation. To summarize, STM stands for Specific Transmission Module, which enables ETCS equipped trains to operate on tracks using national signaling systems. It acts as an interface between national train protection systems and ETCS onboard equipment. The system automatically switches between ETCS and STM modes when the train passes over Euroballasts. However, the supervision level during STM operation is limited to the capability of national protection system. Therefore, STM is a transition technology that ensures interoperability and operational continuity until ETCS becomes fully implemented across railway networks. Okay, thank you.